Today we'll look at systems of inequalities and feasible regions. Warm up. Write the equation of each inequality. So for A, if you take a look, we could write the equation by looking at the slope and the y-intercept. So here the y-intercept is 1, and it's going up 1 over 1. So the slope is also 1, so we can write 1x. And then if I had to guess, like it's above the line, so I would say y is greater than 1 plus x or x plus 1. But in order to see if that's true, you would pick a point, test, and shade. I'm going to pick 0, 0. And if my inequality is true, then 0, 0 should be false. So if I plug it in, is 0 greater than 1 plus 0? And that's false, or it's not shaded, so this is the right inequality. And again, you can switch the order as well. You could write y is greater than x plus 1. They mean the same thing. So let's take a look at the second one. Again, we'll start with the y-intercept at -2, and our slope is negative. So if I pick another point, it looks like it's going down 2 over 1. So we have -2, and it's minus 2x. And again, we're shading above the line, so I would guess y is greater than that. So let's pick a point and test it. 0, 0 does work. And so if this is true in the inequality, then I know I've put the inequality the right way. So is 0 bigger than -2 minus 2 times 0? Which, this would cancel. So we're checking is 0 greater than -2, and that's true. So this was the right direction for the inequality. So definition for today, the feasible region is the set of all possible points or solutions to a system of inequalities, which we call the constraints. So we've looked at this before. So again, we looked at shading the area of all the possible points that work in the inequalities. So again, the name for that is the feasible region, or the region where all of these answers are true for all of the inequalities. So if you take a look, let's just do a problem where we have a bunch of inequalities and graphing it and finding where it's shaded for all of these 4 inequalities. And where it's quadruple shaded, these will be the answers or the feasible regions that's going to be true for all of these inequalities. So the first one is x is greater than or equal to 3. So the x lines are vertical, so I'm going to find where x is 3. And all along this line right here, x equals 3. And if you look in our inequality, it can equal the line. So I'm going to go ahead and make a straight line, and I want to shade where x is greater than or equal to 3, and so that would be to the right of that line. So there's the first inequality. All right, the second inequality, where x is less than or equal to 7. So I'm going to find, again, an x line is going to be vertical, where x is 7. 5, 6, 7. It's going to be all along this line, x is 7. And again, it's equal to, so we'll draw our solid line. And this is where x is less than or equal to. And again, we can shade like everything that's less than or equal to, but we're going to look for the feasible region where it's true for the other inequalities as well. So I'm just going to double shade this area that's already shaded. All right, our next one is y is less than or equal to 10. And the y right here, this would mean our y-intercept is 10. 10 right here, and then it's where it's less than or equal to 10. So again, it's going to be a solid line. The slope is 0, and it's going to be where it's less than or equal to, so we're going like this. Again, it can be like everything below the line, but we're looking for where it's already shaded. And then our last one is y is greater than or equal to -x plus 8. Let's make that, I don't know, orange. And so we'll start at +8. And our slope is -1 because you see this negative in front of the x, and if you don't see a number, there's an invisible -1 there. So our slope is -1. It means from our y-intercept, we're going to go down 1 over 1. And you only need a few points, of course, to make your line, but it helps me to make a lot of points here. So there's our line. Again, it was solid because it's greater than or equal to. And I'm assuming we're going to shade above the line because it's greater than or equal to, but let's test 0, 0. So is 0 greater than or equal to -0 plus 8? Is 0 greater than or equal to 8? That's false. So we don't shade this side of the line, we shade the other side of the line. And we'll shade where it's already shaded. So we're looking at this region right here. So I'll kind of darken that in. And where it's quadruple shaded, this is called the feasible region. So I'm going to go ahead and color that red. And what that means is anything on the line or in this really dark region right here, any of these answers work on the line since it's solid, or in this region right here. And then it does ask, what are the vertices? And the vertices are the corner points right here. And so let's go ahead and label the vertices. So our first one right here is 1, 2, 3, 1, 2, 3, 4, 5. So 3, 5 is this one right here. We go over 3 up 10, so this is 3, 10 for this vertex. Whoopsies. The one over here is 7, 1. We go over 7 up 1, and then 7, 10. So those corner points are called the vertices, and we're going to take a look at why is it important for us to find those vertices tomorrow after we get comfortable like actually finding the vertices. So those are the vertices, the corner points. All right, let's do one more example, and then we'll take a look at taking words and actually doing this right here, and then you'll have practice on this, and that will lead us into our investigation tomorrow. So here's our first example. Y is less than or equal to x plus 6. So we'll start at 6 and make a dot. And then the slope is 1, so we're going to go up 1 over 1. If I go backwards, I'll go down 1 over 1. Okay, and then our line is solid. And we're going to pick a point, test, and shade. So I'll just test 0, 0, which is below the line. Is 0 less than or equal to 6? And that's true. So we're going to shade everything below the line. Okay, our next inequality. Y is greater than or equal to 6 minus x. So again, the y-intercept is 6, but this time the slope is negative 1. So we're going to go down 1 over 1 in each direction. And again, pick a point, test, and shade. So I'll test 0, 0 again. Is 0 greater than or equal to 6 minus 0? And that's false. So right here is 0, 0. So we're going to shade the other side of the line that's already shaded. So we're looking at this region right here. And then our last inequality is x is less than or equal to 4. So I'm going to find where x is 4. 1, 2, 3, 4. And it's all along this line. So again, an x line will be vertical and it's solid because of the inequality. And we're going to shade where x is less than or equal to that line, so to the left. So we're shading this area that's already double shaded, and we'll make it triple shaded. Okay, so now we have our feasible region, which is where it's shaded for all of the inequalities, so it makes this triangle this time. So there's the feasible region. We're going to find the corner points called the vertices. So our first one is 1, 2, 3, 4 up 2, so 4, 2. Our second one is 0 over 0 but up 1, 2, 3, 4, 5, 6. So over 0 up 6. And the third point is over 4 but up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 10. So over 4 up 10. So those are the vertices or the corner points. Okay, so if we take a look at finding a feasible region, again, it's the answer for all of the inequalities, and again, we're going to focus in on those vertices where the corners are, and we're going to do that for a word problem. So, and we've seen this problem before when we were just practicing writing inequalities, so we're actually going to look at an application of this. So, investigation. Ezra has saved up $100 from a previous tie-dye from his tie-dye sales, and from working at Rainbow. He is going to make his next batch of merchandise to sell. Would like to purchase some more sweatshirts and t-shirts to dye. He found a store that gives him a pretty good price if he spends a minimum of $50. The store sells t-shirts for $5 and sweatshirts for $10. He wants to buy at least twice the amount of sweatshirts as he does t-shirts. First step, define variables. Okay, so we have two things. We have sweatshirts, so I'll say X is number of sweatshirts. And then, well, actually I'm going to change it because it goes t-shirt, sweatshirt. It doesn't really matter, but I think no, we can leave it. No, I want to make it t-shirts. Let's do t-shirts. Number of t-shirts. Just so I can keep the order here when I write it. It actually doesn't matter, but here we go. All right, so then that would make y the number of sweatshirts. Okay, so the reason why I just wanted to keep it in the same order, again, it doesn't really matter, but because it just says t-shirts here for $5, and then sweatshirts for 10. And he can only spend at least $100 right here because it's all the money he has. So the amount that he spends is less than or equal to $100. But he has to spend at least $50. So the amount he spends, 5x plus 10y, should be greater than or equal to 50. And then he wants to buy at least twice the amount of sweatshirts. So the amount of sweatshirts should be greater than or equal to twice the amount of t-shirts. Okay, so we got our three inequalities right here. We could add the common sense constraints. X is greater than or equal to 0. Y is greater than or equal to 0, which just means it's positive. When we graph it, we're not going to look at the negative. Step 3, graph each inequality using the cover-up method or solving for y, shade in the feasible region of the graph. Okay, so cover-up method is fastest when you have x and y on the same side. So 5x plus 10y is less than or equal to 100. Let's solve using the cover-up method. So first, let's cover up the 10x, and we get 5x, let's set it equal to 100, and solve. So x would be, divide each side by 5. Whoopsies. So if we have 5x equals 100, divide each side by 5. So x is 20. So that's one point we're going to plug in and solve. So then let's cover up the x, and our other equation is 10y equals 100, divide by 10, so y equals 10. So this is our first inequality. We're going to, when we graph it, sorry, I can't ever click on the eraser anymore after this update. I apologize. Okay, there it is. So when we graph it, we know x has to go at least up to 20 and y has to go at least up to 10. All right, let's solve 2 points to graph our second inequality, which is 5x plus 10y is greater than or equal to 50. Again, using the cover-up method, let's cover up this guy first. So we have 5x equals 50, so divide by 5, x would be 10. Let's cover up the 5x, so we would get 10y equals 50, divide each side by 10, so we would get x equals 5. All right, so we need to graph at least these 2 points right here. And then our last inequality, y is greater than or equal to 2x, and that's a line that we can graph. So when we're looking at writing our graph, we have two variables. Again, we said x is the number of t-shirts, and y is the number of sweatshirts. Excuse me, so let's plug that in. And when we scale our graph, let's take a look at what our numbers go up to. And the biggest x is only 20, so I think we can even count by ones because there's 20 boxes here. So when we scale it, I'll make this 0, and I'll just count by 2's. So 2, 4, 6, 8. So it is going up by ones, but I'm just writing every second number. 10, 12, 14, 16, 18, 20. Perfect. And we can keep going. I guess I should keep going. 22, and so on. Okay, so now when we go to number of sweatshirts, I believe that there's at least, oh, for the y value, you only have to go up to 10, because look at that. 10 is the highest y value. I wrote x equals 5 here. That should be not that. Whoopsies. So let me erase. So right here, I should not have put x equals 5. It was actually y equals 5. Okay, so when we scale over here, again, I'll just go by ones. So here's 2, 4. So every box is 1 unit, but I'm really just writing every second number. Okay, let's graph this. So the blue line, the first line right here, for which is like we can spend at least up to $100. X is 20. Y is 10. All right, we're gonna see if I can draw a straight line here. There used to be a straight line tool if I There we go, held down. And it's a solid line. We're going to pick a point, test, and shade. 0, 0, we can plug in. So is 0 less than or equal to 100? And that's true. So we're going to shade everything below the line. Okay, let's do our next line. X is 10, Y is 5. So X is 10, Y is 5. Again, I'll hand out rulers. We'll draw a straight line. And we're going to shade everything. Well, it's a solid line because of the inequality, but we're going to plug in, again, 0, 0, 0, turn this whole thing 0, right? 5 times 0, 0, 10 times 0, 0. So we're really testing a 0 greater than or equal to 50, and that's false. So we're not going to shade below, we're actually going to shade above. And again, we can shade everything above, but we're looking for the double shaded region, so really I'm only going to shade in here where it's already shaded. So right now our answers are between those two parallel lines. But we have one more inequality, this one right here, which is he buys at least twice the amount of sweatshirts as he does t-shirts. And here the y-intercept is 0, but the slope is 2. So we're going to start at 0 and go up 2 over 1, up 2 over 1. And then I'm going to draw my straight line through those points. And here's an example of where you can't use 0, 0 to test because it's on the line. So it's not going to tell you where to shade. So I'm just going to pick a point to test. I'll test this point, which is 4, 0. Okay, so let's plug that in for x and y. All right, so again, the point is 4, 0. So is 0 greater than or equal to 2 times 4? And that's false. So what that means, that was below the line. It's false below the line. So I'm going to shade everything above the line. So I'm going to shade everything right here. And here's our feasible region. So what that means is anything within this quadrilateral right here, all of these should work in our inequality. So our 4 points, here are the vertices. So anything within that red region or on the lines should work. It says graph, find the vertices. Okay, so one of them is 0, 5, 0, 10, 2, 4, and it looks like 4, 8. It says, give 3 combinations of t-shirts and sweatshirts that Ezra can make. So it could be any of these right here. So here's already 4 of them. Or it can be anything inside the feasible region. So you could say, well, he could make 1 t-shirt and 6 sweatshirts. So anything inside the red area or on the points, those would work. Give 2 combinations that he would not be able to make. So anything outside that feasible region, so like this example right here, 4, 0, that's outside the feasible region, that would not work. You could pick anything in the double shaded or the no shaded region, and any of these points would not work as well. So again, our goal is to find where's that area where all of these inequalities work. And then tomorrow we're going to look at, all right, now that you know that, how can you use this to find maximum profit? So your assignment is to work on day 7, just some graphing and finding the feasible region. And then you have one word problem where you're going to find the region as well.